All right, our next topic we're going to talk about is velocity. The definition of velocity is the speed of an object in a particular direction. So essentially, this is the same thing as speed, but we are going to specify which direction the object is going. So whether it's north, south, east, west, up, down, right, left, we have to say which direction is going because velocity is specifically the speed with the direction that the object is going. So for example, you could say something is going 6 meters per second south. You could say it's moving at 10 miles per hour west. It could, it's moving 2 meters per second to the right. Something along those lines, but you have to label it with a direction and with the meters per second unit in order for it to be velocity. So speed versus velocity, like I just said, almost the same thing. Speed is describing the rate. Velocity has the rate with the direction. So like I just told you. Velocity can change when either the speed changes, the direction the object is changing, or both. So if you have something that's speeding up or slowing down, that's a change in velocity because the speed is changing. Also, if you change the direction, if an object turns, if it's like goes right or left, that is also a change in velocity. Even if it's keeping the same exact speed, part of velocity is the direction. So if it changes direction, then it's going to change velocity. So if it changes one of those or both, you are getting some kind of change in the velocity of that object. So finding velocity is simply just calculating the average speed that we know how to do already. You take the total distance divided by total time, and then you just describe the direction that that object is moving in. So for example, if we have an object moving 60 meters in 30 seconds to the south, you take 60 divided by 30, because that's distance divided by time. That gives us 2 meters per second, and because I told you that it's moving to the south, you would label it as 2 meters per second south. So same exact calculation. If on your formula sheet you want to write out this equation as velocity equals distance divided by time, then with direction you may. It's up to you. If you think you're going to remember it without, it is the same equation just with separate units. There is another part of velocity though that is a little bit different, but it's a pretty simple concept. So if you have something that is an object that is moving on another object that is moving, such as somebody that's on a bus. If you're walking on a bus while it's moving, there's something called resultant velocity. And I know we talked about, at least with one class, I believe 6th hour, we kind of got into this discussion before. But if you have two velocities kind of having to be combined, it's called resultant velocity. So it's a pretty easy equation. So for example, we can have two different scenarios. We can have the objects moving in the same direction, or we can have the objects moving in different directions. So the first one we're going to look at here is when we have two objects that are moving in the same direction. So for example, we say there's a person on a bus, and the bus is moving 10 meters per second east. The person on the bus is also walking 2 meters per second east. So that's like somebody standing in the back of the bus, and they're walking towards the front while it's moving. So if they're moving in the same direction, you have to add the velocities together to find the velocity of the person. So you add the velocity of object 1 and the velocity of object 2 to get the resultant velocity. So in this case, we have 10 meters per second east plus 2 meters per second east, and that gives us a total of 12 meters per second east. That means that person's resultant velocity is a total of 12 meters per second east because they themselves are walking 2 meters per second, and the bus is also carrying them at a rate of 10 meters per second. So you combine those to get the resultant velocity of that person. So if they're the same, you add them together. Again, if you want to write that on your sheet now, if you want to wait till we do some practice problems, that is fine, but either way, that you will want to probably put that on your equation sheet. So you just add them together if they're the same. If they are in a different direction, you have to subtract. So this would be like someone, if you're riding a bus and someone is walking towards the back of the bus while the bus is moving forward. So let's say the bus is moving 10 meters per second east, and the person is walking towards the back of the bus at 3 meters per second west. So here you have to subtract the smaller velocity from the bigger. So we have the bus is moving 10, the person is moving 3, so we take 10 minus 3, gives us 7 meters per second. Now our label in our direction is going to be whichever direction the faster velocity is in. So in this case, the bus is moving east and it has the faster velocity, so it's going to, that means our person is moving at 7 meters per second east. So basically what this is saying is this person is still moving in an east direction. If you're on a bus and you're walking towards the back of the bus, you're still going the same direction the bus is. You're still moving with that bus, but you're just not moving quite as quickly because it's kind of like walking up a down escalator. You're kind of, you know, being counterproductive because you're going the opposite way of the object that you're on. So you were going against the motion of the bus, but the motion of the bus is too much. It overtakes you, so it's going to keep carrying you east. You're just going to be moving a little bit slower, technically, than someone who was just sitting there. So if it's the same, you add them. If it's different, you're going to subtract the smaller from the bigger to get the resultant velocity of that person.